So as was mentioned by Christelle previously, it all stems from the joint, the common will in Europe to move forward with this topic of hybridization between HPC and quantum computing. And so in France, we decided to address it in a joint way between our national strategy for quantum computing and a more European vision to collaborate with other research communities. So first, I will just give you a little bit of context as of where we are in France, where we stand, what we want to work on as a in terms of national activities, and how we want to articulate it with the European federated vision, that is EuroQCS. So at GENCI, we are involved through our HPC, AI, and quantum activities in the National Quantum Plan. And in this National Quantum Plan, there is an initiative which is called HQI, France Hybrid HPC Quantum Initiative. So it's partially funded by the French government, and we tend to also rely on European, regional, and industrial fundings to have a broader vision and broader ambitions for this strategy. So HQI is really dedicated to the coupling between HPC and quantum computing and simulation technologies. It has three main axes, I'd say. So first, and this is something that GENCI is piloting, is steering. It's the provision of, in a coupled way, in a federated way, of various quantum computing and simulation technologies through our supercomputing system, which is Joliot-Curie, which is hosted in the Paris region by the CEA and operated by the CEA. So first, we will provide by the beginning of 2023 some emulation services based on the Atos quantum learning machine, but not only, we will also provide an emulator of neutral atom systems provided by the startup Pascal, and also an emulator provided by Quandela for optical devices. In the framework of HPCQS, as described by Christelle, we will also provide access next year to a Pascal device, so a quantum simulator. And we also applied to the latest EuroHPC call to host a photonic quantum computer in the same modular setup as the Pascal system. And so this is something that I will describe a bit more in depth later on. Around this platform, so we will, of course, be working on the integration of other devices in the future, depending on the maturity of the technologies. And so we have this broad research program on this hybrid platform, which is oriented towards the coupling between HPC and these various quantum computing and simulation technologies through the QLM, but not only. We also have a dedicated research thread on applications dedicated to optimization, quantum machine learning, but also quantum chemistry and the simulation of physical systems. And we are also working on exploration on other topics, such as, and this is one that was previously mentioned by Simone, I think, quantum links for distributed quantum computing. And as we're exposing various technologies in this setup, we are also exploring noise characterization and noise mitigation. And as the key to being successful in such an initiative is to attract as many users as possible and to make sure that they are able to use and to make the most out of this hybrid platform, we have various initiatives of dissemination, providing access to community platforms, trying to develop international collaborations. That's part of why I'm here today. And we also have some programs to develop use cases by attracting industrial players who are trying to identify which use cases might benefit from such a setup. And we are also trying to foster the communication between the different ecosystems in France by encouraging the foundation of houses of quantum that will be connected together and that would also have a European representation. So in this context, we also want to collaborate with a broader European ecosystem. Now we have EuroHPC, which is pushing to promote the use of quantum technologies in a hybrid way in Europe. And so we wanted to encourage our partners to join us in setting up EuroQCS as soon as possible. And we took the opportunity of the last EuroHPC call to leverage what we already learned by setting up HPCQS on quantum simulation and to move a step further and to set up a shared federated infrastructure for European research on HPC and QC. And so the idea was to rely on what was described in the white paper that was mentioned by Christelle earlier, to suggest in our applications hardware complementarity. So we suggested to the GU that they purchase various kinds of technologies so that you can access as a European research organization various devices. We also promoted the fact that we would like to reuse what was already built for HPCQS so that we don't waste all of this hard work for quantum simulation. And we also wanted to share some use cases to promote the fact for industrial players, for example, or for research organizations, that they can test their use cases on different platforms. And as expertise is key and being guided on how to make the most out of these infrastructures is key to being successful here, we also want to set up a high-level support team to pool experts from various countries that are participating in this call to make sure that users have access to the right level of expertise. And so in order to make sure that we collaborate on this and that we share this vision with different centers, we reached out to our partners, so Cineca is one of them, but we also reached out to BSC in Spain, and to all of the applicants to this call to see how we could suggest a common vision to the GU through our respective applications. And with Spain and Italy, we decided to have the same names for our consortia. So we're named EuroQCS-France, EuroQCS-Spain, and EuroQCS Italy, which sends this message that we want to have this shared infrastructure. And we also put in our respective applications a common part on this high-level support team, the fact that we want to share use cases, and the fact that we also wanted to propose complementary hardware to the GU. And we were later on joined by Poland. They decided to use the same EuroQCS name. And we know that we will also have strong links with LumiQ consortium that is led by IT4I, and we know that, and we also want to welcome other partners later on to join this EuroQCS initiative. So now getting to the core of the French proposal for the GU. So it was initiated not only by France but by 5 partners in 4 different countries. So we have the leaders of this application, which are CEA and GENCI. GENCI as hosting entity and CEA as hosting site, because they will be hosting the machine. We also have iCheck in Ireland. They will be working more on the use cases side. We have also the University of Bucharest in Romania. They provided a lot of use cases. And we also included our partner in HPCQS, which is Jülich, to develop this joint application. For France, well, for this application, we will be targeting a photonic quantum device, for many reasons, because this is something that we identified would be a good asset to our research communities, that it's a very mature technology compared to others, and that it also has a native connection with quantum communications, which is a very dynamic ecosystem also in France. It will be coupled with the same HPC cluster as the Pascal machine in the context of the HPCQS project. So here, as you can see, we are reusing the foundations that we set with HPCQS, hosted at TGCC, so in the Paris region. And we tend to reuse as much as possible what was previously developed in HPCQS in terms of coupling and software foundations. So it will also be accessible through the Atos Quantum Learning Machine. And as for the Pascal machine, we will also provide an access to a more dedicated environment closer to the specifics of these photonic devices. And we also were supported by a lot of our industrial partners and our research community that provided a lot of use cases that could be run on this new device. And in the proposal, as I mentioned, we also put a bunch of experts that will set the foundations of this high-level support team that will be devoted to the users of this federated infrastructure.
Thank you.
If you have questions.
Thank you very much. So,
is there any question for Sabine? So, okay.
Thanks for the talk. Can you be a little bit more specific on the type of quantum photonic devices that you're trying to develop?
So we will integrate one. So we will launch a call with your HPC GU next year, most probably. We would like to have a photonic device based on linear optics with high quality photon sources. So this is something that we've identified as being a promising technology. Of course, this will remain open till the last minute.
Thanks a lot, Sabine. So I think that the main part. Oh, Anton, sorry. Let's be quick.
You mentioned as part of the devices that you were planning to integrate this Atos emulator. I was hoping you could say a bit more about what that does precisely.
Well, well, the Atos emulator, so that's an appliance that works on a shared memory platform. So it's not just a software environment, but basically what it does is that it provides different tracks for quantum computing emulation, okay, based on various mathematical approaches. You can, I think on the QLM, you can either choose to emulate a quantum simulator, which is why we could integrate it in HPCQS. You have a simulated quantum annealing track as well. But initially it was more dedicated to gate-based quantum computing. Well, as you probably know, Atos is also an HPC player, so they integrated in this environment some modular pieces that should ease the integration with HPC clusters. Yeah. For example, I think that I remember that working on the integration with generic scheduling systems, which is a track that should help us also move faster with the integration for HPCQC. Yeah.
Thank you. Thank you, Sabine, very much.